on to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV. It just gets better.
Some homework for today. I want to mark. The first was exercise 2 on page 107. They start off and they ask me, kom op gesels. They ask us which distance time graph represents the motion of an object moving at constant speed. If you have constant speed, your distance time graph would look like that. So which one would be the correct answer? It would be D. Number 2, at a sports event, a champion runner and a car take part in a race. The runner runs at a constant speed of 10 meters per second. So it's constant speed of 10 meters per second from the start of the race. Then it says during the first 5 seconds of the race, the car's speed increases from 0 meters per second to 25 meters per second, and it took 5 seconds to do that. On the graph, draw a graph to show the motion of the runner. Well, a runner and a car. Okay, so the motion of the car, they give you the graph grid. They've got 10, 20, 30. And over here we've got 1, 2, 3, 4, 5, 6, 7. All right, so the motion of the car, they say, the runner runs at a constant speed of 10 meters per second from the start of the race. During the first 5 seconds of the race, the car's speed increases from 0. Well, for the first 5 seconds, we have 1, 2, 3, 4, 5, 6, 7. And the speed on the y-axis is 10, 20, 30. So for the next 5 seconds, this car is going to accelerate from a speed of 0 to reach a speed of 25 meters per second. So over there and over there, that would be the spot. You would draw a straight line with your ruler. That's the first 5 seconds. Okay, the motion of the runner, I say he runs at 10 meters per second from the start of the race. So the runner goes there. Are you with me? All right. Now they say, well, okay, use a pen of different color for the second graph. Are you with me? This was the runner, and that was the car. Okay. Number 3, the graph shows how the distance traveled by a vehicle changes with time. Which row describes the speed of the vehicle in each section? Just quickly want to draw it over here. We have that, that, and that, and this is a distance time graph. Yeah, I've done both. Okay. We have P, Q, R, and S. So, how would you describe the motion? Without looking at the table that they give you. As the distance increases as the time goes by, we say he is running with a constant speed. Alright? From P to Q, he had a constant speed. And then? Zero speed because his distance doesn't change. Then he stood still between Q and R. Yes, and then? So? He went backwards, yes. No, do you understand that? Page 108. So, it would be constant speed, zero, and decreasing. No, it's also constant speed, but it's just going in the back direction. Because that's constant, that's just negative. Okay. So the answer would be A. Say again. You would have an exponential curve. Remember, this is a distance time. Dit is waar jy iets op velocity time dink ek. Okay. Ja. Nou, this, luister gou. You have a displacement time graph, distance. So if your distance increases as the time goes by, but your distance increases with a uniform amount, then you have got a constant speed. Remember, if we go back to our graphs, just have a look there. Where are the shapes? Over here. Distance time graphs. There. For constant velocity. What? No, forget about the angle. No, the angle has just got to do with how fast it's going. If it's got a steeper gradient, it's going faster. If it's got a shallower gradient, it's going slower. But it's constant velocity. Okay. Now, where was I last? All right. Then you had to do the check your progress part. Is that right? Yes. Question 1. People, when you do these questions, you need to read very carefully to know whether you are working with constant velocity or constant acceleration. And you need to be careful when you look at the graph to know whether it is a displacement time or a velocity time graph. Do you follow? Okay. So, briefly explain the differences between the following pairs of terms. Speed and velocity. Speed is a scalar. Velocity is a vector. They refer to rate of change of distance for speed and rate of change of displacement for velocity. Instantaneous velocity and average velocity. Instantaneous velocity is the velocity at a specific instant in time. So it's the rate of change of displacement for a specific instant in time. All right, just a split second. Average velocity is the average velocity of the path. You will add up the different velocities, starting velocity, final velocity, and divide it by 2. All right. Positive and negative velocity. Positive velocity, for example, object traveling away from you. Negative velocity would then be object traveling towards you. Okay. The plus and the minus indicate direction, away from you or to you. And it doesn't matter. I could have said the one going away from me is negative and the one coming to me is positive. It's relative. Okay. Number 2, for each of the following motions, determine the distance covered. A cricket ball traveling at 36 meters per second for a time of 10 seconds. All right, so the distance, we know speed, or velocity is distance divided by time. So distance is speed times time. So what's the speed? 36. What's the time? 10. What's the answer? 360 meters. Whose is right? No, you should get that right. Okay. B. A motor vehicle traveling at 120 kilometers per hour for 6 hours. It's the same calculation, except we're working with kilometers and hours. If this one was in minutes or seconds, you would have to convert it to hours. All right. So once again, we want to get the distance. It is velocity times time. So it's 120 times 6 is equal to 720 meters. Any questions there? Kilometers, thank you. Yes, somebody is awake. Jan Ivan. Goodness me. All right. C. A jet aircraft traveling at 900 kilometers per hour for 120 seconds. Now we have an example. One traveling at 900 kilometers per hour for how many? 120 seconds. So you have to go and convert that to hours. All right? So it would be 120 divided by 60 will give me 2. That would be minutes. To get hours, we would take 2 minutes divided by 60 will give me how much? What is the value? Yeah. Okay, so now you can go to the formula where distance is speed times time. The speed is 900, the time 0.03, and that gives you an answer of? Is it right? Okay, 30 kilometers. Yeah. Yeah, be very careful when you do that. You are supposed to put the value into the memory of the calculator. You only round the final answer. You don't round off on your steps. Okay? Because then the answer will become totally inaccurate. All right. Now, the next question. Draw a velocity time graph. Velocity time graph for a car moving with uniform acceleration from 10 meters per second to 20 meters per second. So 10, 20, 30, 40. And the time interval is in seconds. 1, 2, 3, 4, 5, 6, etc. So uniform acceleration from 10 meters per second to 20 meters per second in 4 seconds. 1, 2, 3, 4. There. Why did my graph not start down on the 0 point? Well, they told us that it starts at 10 meters per second. Who made a mistake there? Okay. Then they say, the car then moves with uniform velocity for another 4 seconds. So 6, 7, 8, 1, 2, 3, 4 seconds. So there's the 4 seconds. It's got to move with uniform velocity there. Okay? And lastly, they say the brakes are applied and the car comes to rest in 2 seconds. 9, 10. So there's 2 seconds. So within 2 seconds, it goes from there to there. So that's what the graph will look like. Okay? Yeah. No. No. Say again? Yeah? Yeah. Yeah, but it's going down. No, because it's constant deceleration. Only the deceleration changes is the curve. Okay. All right, now they say, use the graph to find the value of the acceleration for each part of the graph. In other words, what is the acceleration there on that blue line? And what is the acceleration there on the green line? Why do I draw an angle like that? Why have I drawn this black line like this? What must I work out? The gradient of the line. Okay, so you can either use the whole line, it won't really matter. So if we use the whole line, the change in y over here is 20 minus 10. Okay, so for the blue part, the change in velocity is 10 over change in time is 4. So the acceleration is 2.5 meters per second squared. And it's positive. All right? When we go and look at the deceleration part, we can figure out the gradient of the line. I can use the whole part. So now the change in velocity is 20. And the change in time is 2 seconds, which gives me 10 meters per second squared. But what do I know about this one? You must either indicate it as being negative, or you must say it is. Yes, decelerate or retarding. No. All right. Number 4. Any questions there? Okay, Armand, het is goed as jy verstaan. Okay, number 4. A car starts from rest and accelerates for 2 meters per second at 2 meters per second for 6 seconds. It then moves at uniform speed for another 8 and finally decelerates at 4 meters per second until it stops. Draw the speed time graph, right? Draw the axes. This is speed, time. People remember the proper protocol when you draw graphs in tests and exams. You need to label the axis, speed or velocity, and you need to indicate the unit. Okay? You need to name the graph, speed versus time. Okay? Choose a correct scale. Okay, so let's go and do the following. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many do I need? 10. 11, 12, 13, 14, 15, 16, 17. All right? And going up, I need 1. How many? Okay, let's take that. 4, 8. Come on. 12. 16, to where must it go? 16 is enough. Okay. They say, a car starts from rest. There's the 0. Okay. So he starts from rest and he accelerates at 2 meters per second for 6 seconds. Now, 1, 2, 3, 4, 5, 6 seconds. Yeah. No. No. How are you going to figure out what his final speed is going to be? Well, now you have to work the back way around, because they say he accelerates at 2 meters per second. So change in y over change in x is equal to 2. We don't have that one, but we do have that one. So what over 6 is going to equal 2. 12. So the change in velocity starts from rest must be 12. Did you follow me? You didn't follow. Okay? So there goes the first part. Who had that right? Good. Well done. Okay. All right. From that point on, they say it then moves at uniform speed for another 8 seconds. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 8 seconds will be 1, 2, 3, 4, 5, 6, 7, 8 seconds. So he must have constant velocity for 8 seconds. Follow me? All right? And finally, he will decelerate at 4 meters per second until he stops. Now, we have to do the same thing. Change in y over change in x must equal 4. Now, we don't have the y, but we do, no, we don't have the x, but we do have the y. All right. So what is the change in y? It's from 12 to 0. So change in y is 12. We don't know what change in x is, but it must equal 4. So 12 divided by 3. 1, 2, 3 seconds. There it goes. Etium. Say again. Because they said, they gave it to us. He decelerates at 4 meters per second. All right. Now, B. What is the maximum speed of the car? 12 meters per second. For how long was the car traveling in terms of time? 17 seconds. What else could they have asked? What distance did he travel? Let's quickly work out the distance. They didn't ask it, but let's work it out. Yes, so we have a triangle there. So that would be half base times height. We have a triangle there, which would also be half base times height. And over here, we have a rectangle, which is length times breadth. So that one is going to be 12 times 1, 2, 3, 4, 5, 6, 7, 8. So that's 1896, is it right? Meters? 36. Is this one 36? It's half of 6 times 12 is equal to 36 meters. And that one? 18 meters. So now we can go and say, this vehicle, we've got all the accelerations and the decelerations, traveled a total distance of 150 meters, which is 36 plus 96 plus 18. Could you follow me? Are you with me? Okay. Listen, if you've had these questions wrong, you must go back this afternoon and redo them. Okay? Right? No, you can't do it like that. No. No. It's a constant acceleration. The acceleration's not changing. So the gradient of the line must be constant. You understand? This is a velocity time graph, not a displacement time graph. You're confused between the two. If it was a displacement time graph, it will have a curve. But we've got a velocity time graph. Okay, go and check that again. All right. Then you had number 5 as well. Is that right? Okay, number 5. The following graph shows the motion of a boy on a bicycle. Describe the motion fully. All right. Now, it looks like that. There. Oh, gosh. There and something like that. My graph is not accurate. Over here, we've got 10 seconds. Okay, this is time. And over there, we have 25. And over here, we have 30 seconds. Over here, we have got 20 meters per second. So now we have a velocity time graph. Now, can you see that he's accelerating, but that the acceleration is not constant, right? Can you see that? Now we've got the curved side. The gradient of this line is constantly changing. The acceleration is increasing. Yes, increasing acceleration. And then after 10 seconds, he travels at a speed of 20 meters per second for the next 15 seconds, after which slams on the brakes and decelerates rapidly in 5 seconds to come to rest. Are you with me? Yeah. All right. You've still got exercise? 1. Okay, let's go and do exercise 1. That's fine with me. Oh, shame. Exercise 1. An object moves initially with constant speed and then with constant acceleration. Which graph shows this motion? A speed time graph. So constant speed at first has to be horizontal, and then constant acceleration, it should have a gradient. So it would be graph B. All right? Number 2. An object moves with constant speed, but now be careful, what graphs have we got, right? Yes, a distance time graph. So what does constant speed for distance time look like? A line with a gradient. Okay, so the object moves at a constant speed for some time and then begins to accelerate. So we first need a line with a constant gradient, and then it's going to accelerate, it's going to curve, so it would have to be C. Okay, we can do 3 tomorrow. Homework, exercise 1 on page 104. Let's quickly have a look. It wasn't very difficult, but it has got to do with speed and velocity and distance and displacement. All right. So, a train begins a journey from a station and travels 60 kilometers. Come on, stop talking. Hey. All right. Travels at 60 kilometers in a time of 20 minutes. What is the average speed? Now, speed is, come on, what is going on here? There. Okay, so we have to work out the average speed. Speed, people, is distance divided by time. The distance was 60 kilometers. The time was 20 minutes. Now, why do I write it as 20 over 60? We've got, well, the answers they give us as meters per second. So I mustn't divide by 60. If it's 20 minutes, I must multiply by 60, and 60 kilometers I must multiply with? No, how many meters in a kilometer? 1,000. Do you follow me? Yes. So the answer is 60,000 divided by 1200, and 6 will go twice, and 6 will go 1, and 2 will go 50. 50 meters per second. Is there a choice? Yes, number C is 50 meters per second. Who had that one right? Okay, got him a few. All right. Yeah, be careful there. Because if you divide, then you go to hour. Because that's what I wanted to do before I looked at the question properly. Ne? I wanted to go to kilometer per hour. Okay, people, important. You must check the unit. Because when I started working, I wanted to divide by 60. Because I wanted to go to kilometers per hour. But the answer that they gave us, the choice, is as meters per second. So you must convert to meters per second. All right, number 2. A car travels at an average speed of 60 kilometers per hour for a time of 15 minutes. Now, how far does the car travel? Now, people, the problem over here is the speed is kilometers per hour, and the time we've got is minutes. So one should convert that one to hours. So 15 over 60 is equal to a quarter of an hour, ne? 0.25 hours. Are you with me? Who can't follow? Okay? Alright, so now we can go and work out distance. Distance is going to be speed times time. The speed is 60 kilometers per hour. The time is quarter of an hour. The answer is 15 meters. Is there 15 kilometers? Sorry. So it is B. Any questions there? Any questions? Okay. Whose was right? Nobody. Right. Well done. Good. All right. Then number 3. Okay, number 3, a car travels along the route PQRST in 30 minutes. Now, PQRST, we had P, we had Q, we had R, we had S, we had T. This is 10 kilometers, that is 5 kilometers, that is 10, and that one is 5. Now they say, what is the average speed of the car? Well, speed is simply distance divided by time. What is the distance? 10 plus 5 plus 10 plus 5. It is going to be 30. Is it kilometers? Kilometers. And the time they say is 30 minutes. So we need half an hour. No? That gives me 60 meters per second. Kilometers per hour, sorry. Yes, kilometers per hour. Who had that one right? It is D. Yes! Okay. All right, people, that was that. All right. All right, people. Are you with me with the difference between distance and displacement and speed and velocity? Just to recap, distance is the length of the actual path followed. Yes? Displacement is the straight line from the beginning to the end in a specific direction. And then we get speed and velocity. Speed is a rate of change of displacement, because speed is not a vector. And velocity is a rate of change of, speed is a rate of change of distance, because distance is not a vector and speed is not a vector. And then velocity is a rate of change of displacement, because there is a specific direction to it as well. Okay, now we have to have a look at graphs of motion with distance time graphs. Okay, so when I have a distance time graph, it can have one of those shapes. If I have zero velocity, it's simply going to be a straight line. If I have constant velocity, it is a diagonal line, a line with a gradient. And when I have, for example, constant acceleration, in other words, my velocity is changing. Yes. All right? Because at that point I have one velocity, at that point I have another, at that point I have another, at that point I have another. I'm going faster and faster and faster and faster. This is what the graph would look like. Okay? If I'm accelerating, my distance time graph looks like that. All right? Now, in the next set of graphs I have on the board, these were distance time graphs. Okay? Here I have speed time graphs. If my velocity is 0, then here we have velocity and there we have time, so that is what my graph would look like. As the time goes by, my velocity is 0. Or speed is 0. If I have constant speed, I am driving along at 3 meters per second. So the first second I'm traveling at 3 meters per second. The second second I'm traveling at 3 meters per second. The third second I'm traveling at 3 meters per second. I have constant speed. No. You are moving at 3 meters per second. Draw the graph. Okay. All right. Now, if you have a constant increase in speed, in other words, you've got constant acceleration. In the first second, you're going at 2 meters per second. In the second second, you're going 2 meters faster. You'll be going at 4 meters per second. In the next second, you'll be going at 6 meters per second. In the next second, you'll be going at 8 meters per second. Then your graph will look like that. Constant acceleration. That would be positive acceleration. What does positive acceleration mean? Going faster and faster and faster. All right? This graph over here is also constant acceleration, but what am I doing? I'm slamming on the brakes and I go, stop. You're pulling away from the stop, and you go faster, 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 and here you are approaching a robot, you slam on the brakes, you go slower, slower, slower. Okay, just have a look at our graphs. We had a distance time graph, and we have a velocity time graph. And this is the shapes they can have. All right? Now, you need to know what they mean. Here I have an example. The first thing you need to look at is to see, okay, I have a graph. And the question says, discuss the motion of this object. Just want to lock it. Okay. Discuss the motion of this car or bus. How do we do it? Well, we need to know, okay, I have a speed time graph. So, I am busy with, here's my speed time graphs. Look at it. If my speed time graph looks like that, my speed is 0. If my speed time graph looks like that, I have constant speed. And if there's a gradient, I'm accelerating. So let's go back to the diagram over there. Can you see What have I got over here? Yes, it's that one. So, for the first 5 seconds, the vehicle accelerates constantly. Can you follow that? Then, for the next, how many seconds there? For the next 5 seconds, what have we got? Yes, constant speed. The bus is traveling at constant speed for the next 5 seconds. Alright? And then what does the bus do? Yes, he decelerates sharply over a period of 3 seconds. And then his speed is 0 for 3 seconds. Can you follow that? And then what does he do? He suddenly accelerates to reach a speed of 5 meters per second. There was a dog in the road. Okay? And then he continues with constant speed. Would you be able to do that? Okay? Because you will definitely get graphs to be interpreted. No, hang on. All right. So, here we have another graph. Now, you have to look. The one we've just looked at was a speed time. What have we got here? Distance time. In other words, now we are busy with these graphs. Okay, distance time graphs. That one is zero velocity, that one is constant velocity, and this one is changing velocity. I'm sorry, the board moved, so everything is disrupted. Okay, so we must work with these graphs. So let's go and have a look. Now, car starts from rest, and it travels at constant speed for 20 seconds, covering a distance of 2 meters. Yes? Well, it doesn't really matter. Speed is fine. Okay? Then, what has he done over here? Yes, he stood still for 10 seconds. No? It's a distance time graph. Then he started moving once again. Constant speed for 5 seconds. Because there's a direct proportionality between distance and time. Okay? And lastly, the D section. Well, he's standing still again. Okay, after he has traveled a distance of 4 meters, he stops. And he stands still for the last 10 seconds. Are you still with me? Yeah. Yeah, you're talking about distance time. Okay, now, I'll come back to these graphs in a moment. Here we have another one. Here we have a velocity time graph. Okay, or a speed time graph. So now we're working with the second set of graphs again. Okay? What has this person done? He started from rest. Okay? And he accelerated for 10 seconds. Then he traveled at constant speed of 60 meters per second for 5 seconds. Then he decelerated over here. Can you see he had 0 meters per second? What has he done? Yes, he's reversed. Okay? And then he accelerated, well, he went forward again, accelerated forward. Well, I started over here, okay? I went faster and faster, and then I had constant speed, and then yes, yeah. Okay. So he went back further than where he started from. All right. Now, because there is the 0. Here we have a negative velocity. What's the difference between a positive velocity and a negative velocity? No. 10 meters per second is 10 meters per second. If I have positive 10 meters per second, he's going forward. And if I have negative 10 meters per second, he's going backward. Well, there, he went backwards because that line's gradient is negative. Yes, there. Because there he went past his starting position. And then back. No. No. Just listen. Listen. He goes forward. Faster, 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 faster. He's still going forward, constant speed. And now he goes backward. Well, forget about the break. Yeah. Well, he is over here. He started, or he ends with 0 velocity. Yes, he slammed on the brakes. That's right. Okay, and then he started to reverse faster and faster again. Hey. Okay, now I want to go back to the original graphs that we did over here. Let me just lock this thing in place because honestly, I don't know why it jumps around. Now, come on. Okay, I just want to lock it, lock in place. Okay, now, how do we determine speed or velocity? Distance divided by time. Okay, how do I get distance? Speed times time. Okay, over here, we have the same formula. We said speed is distance divided by time, and distance is going to be speed times time. How do I get acceleration? Who can remember that? Change in velocity over change in time. Okay, now, have a look at these graphs. Just have a look at this graph. Here I have a distance time graph, which means I traveled to a distance of 3 meters, and from that point on here, when I started measuring my time, my distance did not change. Are you all with me on that? So we said, I am standing still. My speed over here is 0. V is equal to 0 meters per second. Are you with me on that? Now have a look. How do we work out the gradient of a line? The gradient is change in y over change in x. Okay? Does this y-axis have a change? No. But my x does. So 0 over anything is 0. Have a look. What is my y-axis? Distance. Okay? What is distance divided by time? Speed. So, when I have distance time graphs, the gradient of a distance time graph will give me the speed. Look at this one. Here I have a line with a gradient. So let's just go and say time traveling, there we go, Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And over here we have 2, 4, 6, 8, 10. Okay. 4. And over there. All right. Now, can you see you can work out a gradient of that line? Yes? Change in y over change in x. Can you see that for this line, the value for change in y over change in x, does it differ? No, it's going to be the same. The gradient is constant. Okay? Look at the velocity. No? Distance. Time. How do we work out speed? Distance divided by time. Here I have y divided by x is the gradient, which happens to be distance divided by time. So the gradient of a distance time graph gives me speed. All right. Does this gradient change? Nope. Whether I take the gradient there or whether I take the gradient there, is it going to change? No. So, when you see a graph, you go and check, I have a distance time graph. Oh, the gradient of a distance time graph gives me the speed or the velocity. Yeah. Well, technically, the size of it is the same. All right? The gradient of a line that increases from left to right, in other words, that goes up from left to right, is positive. If my graph looked like this, then it's going slower, slower, slower. Or the direction is going to be opposite to that one. No. That would have a negative gradient. Look at this one. Here we have instantaneous velocity because my speed is changing. Can you see at that instant of time and at that instant of time, if I worked out the gradient of the line at that point, now how do we do it? Now this is actually a higher level question. They won't expect you to work it out, but there is a way of doing it. We simply draw a line with a ruler at a tangent to that point. Now it's difficult for me on the board because my lines are too thick. But if I want to work out that one, then I draw a straight line that connects up with that spot. There. And then I go and work out the gradient of that line. And that would give me the instantaneous velocity for that split second in time. And over here, my gradient is going to differ. Can you see? Something like that. So I work out the gradient of that line, and I will have its instantaneous velocity at that point in time. But they won't expect you to work it out. All right. The gradient of this line changes continuously. It must go on. It's difficult. It must go perfectly there, a tangent to the spot. Okay. A tangent is a line that just touches at one spot. All right. And you work out the gradient of that. But this you must know. Okay. Change in y over change in x. No. Let's say I had 10 over there and 4 over there. Let's say I had, let's say 2 and 5 over there. Now, how do you work out the gradient? It is change in y, so it is 10 minus 4 over change in x, 5 minus 2. So it is 6 over 3. It is going to be 3 meters per second. All right? In x. Okay. People, that is for the distance time graph. Yes. Is it 2? Oh, thank you. So this is going to be 2 meters per second. All right. Are you with me here? I want to look at the speed time graphs. Yeah, it's always a different cup of tea. All right, now, with a speed time graph, we can also work with a gradient. But in this case, the gradient is going to give me acceleration. How do we get acceleration? Change in speed or velocity over change in time. So, over here, is there a change in speed? No. So is there any acceleration? No. Over here, is there any change in speed?